or even before?
Sir, you are live, sir.
Hello.
You are live, sir.
Yes, I understand that is there. And should we begin now or we should wait for the students?
You
So
can,
they
you can,
are
sta- you can start, sir.
okay, fine. So yes, in this course, first of all, I would welcome each one of you who are here, who are attending this live session. So this is NPTEL course on industrial robotics theories for implementation by Dr. Arun Dayal Udai, that is me, hosted by IIT ISM Dhanbad and simultaneously by IIT Kharagpur as well, and overall host by IIT Madras. So yes, this course almost we have covered. So let me just share my screen. I'm sharing this one. So yes, so far we have covered module 0, that is week 0. We did introduction. You saw we had introduction to the course, goals of the course, prerequisite, what will do, will not do. So those things you have learned. So you have seen in the introduction robot definition, applications, different applications you have seen already, technical specification as well. So you are now understand how important is technical specifications. This is for all industrial users as well as for academic users. It is of very much of importance because for industry day to day, you understand you have to apply your robot for different purposes. So this module basically helped you in selecting a proper robot and selecting its specification for a given application. Okay, so definitely this must be helpful for industry people also. Definitely it is there for academic reasons as well. So you saw it is there with quite much of intrinsic detail that I have tried to cover so far. Okay, so you have seen, yes, it has ISO certification details, payload category, how they are defined, how it is classified, how it is used, including the weight, add-on weight, which is there on the link also. So we have defined mostly as much as possible different technical specifications here. I hope you have gone through the technical specification sheet of different industrial robots that I have shared. Hope you have gone through that. If not, please go through that. That will help you to further understand how closely this course matches to the actual industrial thing, right? So same with the anatomy part, what all things that make up a robot. I gave you a live view of my lab where I have Yashikawa GP12 robot installed with its controller YRC1000. So I opened up the cabinet. I showed you all what all things which are inside. Controller board is there, a PC is there, right? IO systems are there, safety devices are there, emergency panel is there, teach pendant is there. So you saw the standard layout of an industrial system over there. So that was covered in our class industrial robot anatomy. Okay, so those were the live sessions where I took you to my lab also. Okay, and then you saw robot classification where I showed you different types of robot, real industrial robot videos also in working, how they are classified and how different robot is applied for a particular application. In a special part of this module was serial robot and parallel robot. Although I intended to cover wheeled mobile robots here, but due to the time constraint, I could not cover it, but still parallel robot was included, which is normally a part of industrial robot, mostly when it is applied for any agro, food beverage or pick and place industry, there it is applied. So I have shown you the application of parallel robot also. So this was a standard takeaway of this first module, first week course. I hope you have appeared for the course as well as the test which was there. So assignment was very much quite okay, which was very much relevant to the course content directly. Okay, so that was there. And in the second module, you saw 4 different kinds of motors. First one was brush DC motor, permanent magnet DC motor. Second one was stepper motor, BLDC motor, and AC synchronous motor. 4 different kinds of industrial motor, which are very, very commonly used to make industrial robots. So we have covered the prerequisites, basically a small thing, that is physics part of a DC motor first. Then we went ahead and we covered them all. So you saw I used H-bridge motor drivers for demonstrating the thing, right? At least in case of a DC motor. You saw we gave you some examples of real application, how these motors can be used with different kinds of industrial driver. I used Beckhoff drivers for no particular reason. There are many other similar drivers which you could use. They are there in the industry. So this module in a way was very, very helpful in a way when you have to make a robot or you have to understand a given robot, or sometimes what happens in older academic institute, I have seen these robots are just write off. Okay, they are just thrown off if the controller goes bad. So you can pick up one of them and make it operational once again, if provided you understand the principles of actuators and the forward kinematics, inverse kinematics, which comes later, right? So actuators was covered very much in detail, what I understand. I showed you industrial servo drives, industrial drivers for stepper, BLDC motors, AC servo motors, where I made them to run using those drivers, apart from the theories that was covered. Okay, so again, those were from my lab, and I have shared some of the motor data sheets also. At least for the Maxon motor data sheet, I have shared it in the resources section. You can go through that, you can understand that, and try to go through the motor drivers which I have covered. I have explicitly shared all the technical contents over there. So you should go through that, I would suggest. Same with the sensors. Sensors, I have already included different kinds of sensor which are very, very popular in the industry, right? At least industrial inductive sensors, capacitive sensors, proximity, those are used as a proximity sensors. Optical encoders, incremental as well as absolute encoders were covered. Hall effect sensors are covered. Resolvers, synchros were covered. So mostly different kinds of sensors we have already covered. So I hope this is also covered very much in detail. I have also shared some of the data sheet of industrial robot sensors. If at all you want to see the exact circuit, I'll also share it at the last module. One resource video I'll create in the due course till before this course ends. So that also I'll be sharing. Apart from that, will be a bonus for you that actually will show how industrial sensors are integrated to different IO modules, and IO module can be used along with the PC, or it can be connected through standard Ethernet channel to internet, and where you can make it an IoT device also. So that is a possibility which you can definitely take on, and you can do that yourself. Although it is not covered, IoT systems are not covered in this course. That is beyond the scope of industrial robotics theory. But still, I would suggest you can go through that. The fourth module so far, which is there, is degree of freedom transformations. Those were covered. So hopefully you are already into this week now. So almost over with that. So you will be having test at the end. So this will cover both basically degrees of freedom, robot manipulator, kinematic transformation, translation, as well as rotation, vectors, homogeneous transformation matrices, arbitrary axis rotation, DH parameters. That is one of the most important thing that will be covered in this module itself. Okay, so this is one of the most important module you see. Apart from these the module 1 to 3, first one was introduction, second one was actuator, sensors. They are mechatronics aspects of industrial robot that is covered here in this course. So from here onwards, from module 4 onwards, you will find you have syllabus which is directly from the academics point of view. They are very, very important. Apart from what it is, the importance it has in the industry as well, when I'll be teaching industrial robot calibration, tool calibration, circular table calibration is there, and linear rail calibration is there. So those are the direct part where these kinematic equations, these kinematics techniques are utilized. So I would suggest this is one of the most important syllabus which is there academically as well as industrial users. So this has to be there. So this is there. Okay, and next is definitely inverse kinematics and differential motion analysis. From here onwards, we are very much inclined towards all academic learners of this course. Okay, so till here for module 4 and 5 will be forward kinematics. Only kinematics is there so far. Okay, apart from what you have like differential motion analysis is also here. Okay, so rest of the syllabus as will be revealed, you will find it, they are very much applied in a sense. They are will be directly covering tool center point calibration, 4-point method. So these things, what I have seen, it is already there in the manuals only. And no robot manufacturers will tell you how exactly it is functioning behind. Not even, they are not covered in the class book syllabus also. Okay, any classroom syllabus or any academic syllabus. So I have taken these directly from KUKA Industrial Robot Manual and Yaskawa Industrial Robot Manual and ABB manuals. So they all use these techniques to do it, but it is not revealed in any of the book, and that will be covered in your 6th module, that is Industrial Robot Installation and Commissioning, where you will find a video where I am installing a robot from a scratch when it is grouted to the ground, and we'll put that to use. We'll start mastering this robot. You will learn what is mastering. So you see, somebody who is from industry, you see, this is, I'm talking about something which is you are day to day, every day you are doing it, right? You do it every day, right? In a day-to-day application, you do it. So yes, that is the reason the secrets of those day-to-day job is not revealed here. Got it? So that this module is not there in textbook, but it is here in this course. You can document it well, prepare your own notes and see how it works. So this will be very, very helpful. Calibration of industrial robot systems. Again, this is on similar line, it is here. So these two modules are going to come, which is directly covering all the practical things, which are very, very new to the audience here. Okay, statics is there in the textbook, and for academic reason, definitely it has to be there. But yes, force and velocity ellipsoid is covered very much in detail here. And later on, you will find you have robot dynamics. I have tried to cover as much as possible. This is going to be one of the biggest module of this course. Yes, it has to be because it is dynamics. It has to be long. Doesn't matter. It won't be that rigorous though. I assume so far the quizzes which were there at the end of the course were very much trivial, very much easy, no? So because it talks directly in relation to the subject matter which is covered in the course. Okay, but end exam will be very much choosy here. I won't be selecting each and every aspect of the course because the syllabus as such is very vast. So, but you should be ready with academic stuffs, but the questions will be easier than, I tell you, it will be easier what is there in the assignments. So if you are doing well, each module well, all assignments you are doing well, so hopefully you should be attending your end examination much better. Got it? So this is how we'll be moving, the way we are doing it. I have tried to cover as much as possible ISO certification also time to time. Robot controllers I have dealt with here, right? Industrial robot safeties and norms is there at the end, including robot programming. Robot programming is there in quite a lot of textbook I have seen, but industrial robot safeties and norms, this again is something very new to any course which I have seen so far on robotics. So this is very, very important for industrial robots users, right, who are working every day with the robots. So yes, this is very, very important for freshers who are about to join any robotics industry or into any robotic business, definitely this is of very much importance. So be prepared and wait for something new, at least in the module 12 and calibration. Okay, these will be takeaway of this course. Okay, so that's all from my side. If at all you want to ask anything, you can ask it here, or maybe in the channel you can directly post. I'll answer them here. Okay, so I am stopping this share here. Is there any question here? I am ready to take the takeaway of this course. Okay. So I am expecting any queries if you have. Definitely, Saurabh Biswas, you asked about some of the research overview. So you see, this is an industrial robotics course. It is very much limited in a sense. Industrial robots are limited because you see, it doesn't allow you to do much of a stuff in that kind because they are not a torque controlled robot. But still, you see, I have given some inputs at the end where I have used industrial robots with external programming tool like Python, C Sharp, C++, and those kind of stuff, where you can use industrial robot to integrate with your standard PC. Okay, and then you can put any advanced algorithms to use these kind of robots to do your research stuff. So I'll give you an example. When we are in our lab, we have integrated Yashikawa GP12 robot using API which Motoman API, which is there, that can be used to integrate industrial robots to standard PC-based programming. We have integrated with Python. We are trying to do some micro finishing stuff along with my co-researcher, Professor Jafar Alam. So yes, so that is the way we are able to do this kind of. If you have any specific research query, definitely you can ask it here itself. Yes, Sora? Hope I have answered you well. What I'll do, I'll show a glimpse of what I am going to cover in a few more lectures, which will make you very much inclined towards the course. I'll just show you some glimpse of calibration slides that I have made. Okay, so yes, in the module 7, what I am telling, this will be a new takeaway of this course. How does it look like? What all things that I'm going to cover, I'll cover. I'll just show you some glimpse. Okay. So this is going to be my some add-on course, add-on things which is there, that is on calibration of industrial robot. So what you see here is basically a linear rail on which you have mounted an industrial robot. Okay, so this is now on a rail and there is some mismatch. The way it's looked like geometrically, these axes should be aligned with the global axis which is there in the frame. Okay, so that is their universal frame which is there that you see as L, linear rail frame. With respect to this R is, we assume it is ideally aligned, but they are not. So how to find out that? So there are methods for it, which normally industrial robot manual says you do few exercise and you find out the transformation matrix, that is the error over here. Okay, so that is what we call it as calibration. And this is what we are going to cover in week 7. So this is how you do touch from one side, you do touch from another place, external reference frame. And finally, after doing all those exercise, it quickly tells you the transformation matrix which is the error, which is the calibration matrix, we call it. So that is in between L and R. So that is to be identified. So robot manual, what they said, you just take it to a place, touch it again, touch it the third time, and finally it gives you a calibration matrix. Just press OK and it lets you work with that robot on this linear rail. So how does it work actually? So that is something which is not covered in quite a lot of test books. So that is covered here. So again, going on, so these are all mathematics that you are going to learn here, right? So as a similar thing is a turntable. If it is an external turntable, so likewise in the application portion, you must have seen a video where a robot is doing CNC milling on a rotary turntable. So rotary turntable is like this. You can mount some object on top of it, and you can do machining on top of it. Right. So this is a very good application, which is only possible when these frames are all calibrated with respect to each other. You should know about which axis it is rotating with respect to your robot frame. So these mathematics. So again, robot manuals that allow you all these exercises to be done. Okay, they will let you do some few touch-ups, okay, brushings on these tools, okay, external turntable, and it will let you find out the error which is there, that is the calibration matrix which is there automatically. Okay, it won't tell you what mathematics they have done. So these kind of mathematics, you see, it is covered here. So these are the 4 points where they will make you touch. Okay, and then this is the frame which is going to be identified with respect to your robot frame. So this is what is again a new takeaway of this course. So where you will be learning how to calibrate such external reference frame. Okay, so those mathematics is here. Again, you have a workpiece which will be found out. Okay, so workpiece frame is also to be found out. So how to do that? So these are some takeaway which should excite you. Why this is important? Definitely it is of importance. Industrial people, they know it. You can see a lot of video on internet which will definitely fascinate you. So yes, these are a few things that I assume it is very interesting to you as well. A similar one I'll show you. Week 7, that was, yes, fixed tool calibration is there, work surface calibration. So I'll show you one more slide view of this. This again is very important in the industry. I'll show you that, just a sec. You see this is there. Okay, so you see you have external tool piece calibration is there. So this is what in day-to-day job people do it. Okay, you have a welding attachment that is made to touch an external TCP, and I want to know where is my TCP, right? And how is my TCP of the new tool which is attached, that is to be found out. So these are different techniques which are mentioned, 5D techniques, 6D technique. So these techniques also I'll be covering later in this course, you see. So these this figure itself speaks a lot. So this should find you some interest in this course also, because they are very widely applied. Okay. So, and you won't find it in a textbook what you are going to learn in this course. So this is a direct method, indirect methods are there. You have a workpiece which is mounted here, and you have an external TCP. So these mathematics will all be covered in this course, you see. And you have a bigger workpiece and a similar thing. So how to calibrate those? So these are some of those contents that I'll be covering. Okay. Apart from this, there are many other tools. So I am expecting few more questions here. Yes, definitely there are future aspects. Definitely, if you want to do higher studies, there are future aspects for sure. Okay. And but yes, in the industry nowadays, you see you have cobots also which have come up. Industrial robot teach pendants have become very advanced nowadays. So these mathematics will help you to understand all those things what is covered in the manuals now and the future manuals to come. If you want to make your own robot also, you should include all these contents, what industrial robots are supplying, industrial robot manufacturers are supplying, like KUKA industrial robot or Yaskawa industrial robot. They are all supplying these features in their teach pendant. If at all you want to make your own, you should be including all these to your robot also, provided, because you should know these mathematics first. Once you know this, definitely you can do it, right? So that is the reason it is covered in this course. Okay. So any other query from the group? See, space science is altogether a different story. But yes, if you just remove the gravity portion, you have many problems. One of the problem in space, I'll tell you. Just a sec.
Docking station, sir. Docking station in ISS. It uses
Yes,
parallel robot.
yes, I am. Just a sec. Yes. So yes, let us say you have a robot like this, where you have a floating base system, right? It is normally grouted to the ground. So what happens in space, you have this type of system, you have a robot with an extended arm. Those robots which are used in space, they have a huge boom. Okay, this length is quite long. Okay, what happens if it is docked over here? If this tries to pull another satellite to its own space station, not just it will be pulling that satellite to its docking station, this itself will be pulled towards that satellite. Okay, so there are reactions which are very prevalent there. Okay, so those things you will have to control. So apart from it is not like a grouted robot which is not going to move. Right. If you do something, you always see some reaction. So there is a special research topic which is there, which is known as a floating based system, floating based robot, where you have reactionless motion that you have to do. You have to move this robot in such a way that you don't move your base. Sometimes what we practically do, you have two arms. Okay. If you just move one of the arm in one direction, you will be pulled. But if you move both the arms together so closely, then one of them will be annuling the reaction forces which are going to come due to the previous one. So that is what I meant. So these are few research topic which is there in robots which are there in space. The industrial robots which are used in space is very much like the robot that we are learning. So forward kinematics, inverse kinematics, dynamics, nothing is going to change. Only thing which is going to change is this robot base is no more mounted enough on a fixed ground. Right? These booms are very long. Apart from this being very long, another very big challenge when these booms are long is flexibility in the link. So we have also covered, we have seen how these links, we have so far assumed that these links are very stiff in nature, but normally they are not. If it is a space robot, these booms are very long. We will have to consider this link not like a stiff rigid body, they are flexible links, right? The links can flex also. So due to that flexibility, dynamics changes, right? Your accuracy at the end, that changes. So how to deal with those aspects? So these are few things which are also to be dealt when you talk about space robots. So space robots, apart from the kinematics, dynamics, most of the things remains the same. The foundation remains the same, but the dynamics changes, the type of accuracy which is changing due to the, you have to analyze everything not like a rigid body, you may have to take it like a FEM based approaches. So that is used, right? So there are these are few challenges which are there in space robots. Okay. in robotics, normally you don't have DC motors nowadays. DC motors, at least with the motors which are there, which were there with brushes, they are no more there because they require a lot of maintenance. They have short life also. So that is the reason DC motors, at least brush DC motor is no more there. Okay, so what do you see in cobots? You see mostly brushless DC motor, which are there, direct drive kind of stuff, which is there. Okay, so yes, yes, that is the kind of motor that you see. So mostly you will find industrial servo motors. They are PMSM motor. That is permanent magnet synchronous motor. So the fourth actuator that you will be learning in the module 4, that is mostly used in the module actuator. That is the week 4, which is covered just now. DC motors joint. Sometimes we see overshoot in the output torque from these DC motor. See, torque is something which is required. Overshoot is there in terms of what it is achieving due to that torque. Okay, so what happens? That is what we'll be covering in the control also. When you see you have to control your joint position precisely, it is driven by torque, and you have to control the end effector position. If it is a PID control, which is covered in the module control, so in there you will find it is tending to overshoot at the end effector position level. Okay, so when that happens, the controller gains are to be tuned. How those are tuned, the bit of that we have discussed in the module over there. So that can happen. Okay, that can happen. That is always there. Okay, but they can be precisely taken care of with very good controllers which are there. Like PID works well in industry. There are advanced techniques definitely, but because industrial robots, as I have explained there also, they have a huge gear reduction at the gearboxes, so it can be taken care of very easily. Mobile robots, we should not talk about here definitely, because you see mobile robot is not covered in this course. If you, yes, definitely, if you want to mount this robot on top of a mobile robot, then you should be worried how much torque, reaction torque, which is going to come. Okay, so that is what you can study over here. So maybe using Newton-Euler formulation, you can attach this force also to your model, and you can obtain how much forces and torque which is going to come here. So definitely that you have already found out. You using a dynamic method that we have taught in this course. So you can find out how much torques and forces which are going to come at the foundation, and that is what is applied to the where it is getting mounted. So if it is mounted on top of any moving robot, so those forces your mobile robot should be able to take up, those dynamic forces, not just the static force due to its load. You have to take care of that also. So that is there even with the cranes. You see, if it is a crane with a huge boom, so what happens when it lifts up and it is also trying to turn around? So it sees a third direction torque that can topple the robot, or gyroscopic torque is there. So that can topple whole of the crane system. So same thing can happen when you have a robot mounted on a mobile platform. That is normally there in case of any, let's say, bomb diffusal robot, to be just one example I am giving. When you have a bomb diffusal robot and you have a arm which is mounted on a platform which is moving, to say. Okay, so those kind of application is there. Yes, any other query from anyone can take up? So till then, other people joins. I can continue a few more stuff if you want, what you are going to cover in next module which are there. So again, a very important module I'll show you. Safety stuff, which is there, lecture slides. Again, this is a module which is on industrial robot safety. Okay, so we'll be covering very much upon operator safety, safety triggers, function, and those stuff which is there. You see, again, I have covered a lot of machinery directives, BIS standards, ISI standards, the different standards, how industrial robot, they take care of these safeties when they actually design this industrial robot. So industrial robots are not just a research robot which can just do pick and place. They have to be very much compliant to the kind of demand which is there in the industry. So yes, so our course also caters to those kind of audience who seek to understand industrial robot safety and norms that govern. So these are few things that I'll be covering. So what are different standard terminologies which are there when we talk about those standards? So apart from ISO 9283, which was there that you have covered, that we have covered in the industrial robot specification, these are few more standards which are there, which I would suggest if you have an access to those standards, you can go through that, or a part of those I'll be covering in this course. So these are some safety functions that I'll be covering. Okay. So industrial robot, what are the working modes which are there, how teach dependent looks like, what are additional parameters, additional controls that they give you, right? So those things we'll be covering. So yes, these are few standards that I'll talk about. So you see, there are many standards which actually industrial robots they are using. You see, so try to get hold of these safety documents. You can just Google out. Summary is there over internet, but full document, maybe your institute is having access to them, or if it is an industry, you can have those access also. Yes. So these are some norms that I'll be covering. Okay. See, to calculate position of a robot in a 2D plane, that you will be doing in forward kinematics. That is trivial. Okay, no big deal. You will be doing it. Immediately after that, you should be able to understand. But if at all it is a gyroscopic data, gyroscope, what does it give you? It gives you a rate of change of those values, right? It doesn't give you precise angular position. So you have to integrate that. So gyroscopic data is not normally used alone. It is always used in conjunction with other sensors, mostly the position sensors. In case of MCU 6650 that you have seen in your embedded system probably. So what does it have? It has many other sensors as well. It doesn't have just the gyroscope. So it uses a tilt sensor. So how that tilt sensor is used? Tilt sensor is basically accelerometer, three-directional accelerometer. So when you have a accelerometer will give you components of G along X, G along Y, G along Z. Using those components, you calculate the tilt of your device. Tilt of your device. So that is the angle of your device. So that is what you can precisely obtain. But yes, gyroscope is also there. Because calculating tilt beyond 85 degree, 80 degree or so is quite erroneous. So then you start using your gyroscopic data to integrate your angular velocity and get the angular position. Okay, apart from that, to calculate the yaw angle, you also have a magnetometer to calculate the yaw angle. So you have at least three sensors here. First is your gyroscope. Next is your accelerometer that tells you the tilt. And the third one is your magnetometer. So using that you calculate, not just by using the gyroscopic data you can calculate, right? So this sensor alone is not enough. It is used mostly in case of inverted pendulum and those stuff where you are willing to see the angular velocity only. Okay, wheel and encoder data that is responsible for movement of any object, any robot, mobile robot in space. Again, they are holonomic and non-holonomic system that is to be understood. And without having those prerequisites, which is not covered in this course, discussing that over here will not be a good forum. Definitely, if you feel you want to write me directly, you can write it to my TAs also or to NPTEL channel. You can post it in our forum. I'll definitely answer you more specifically, right? Data global time or time stamp of each input. Definitely, you can attach a timer chip also. Apart from what you have, accelerometer, tilt data, gyroscope data in your embedded system, you can also have a timestamp if you have a calibrated time chip, right? So timer chips are also available. You just need to attach it. So when you acquire data, you acquire, let's say, A, B, C values, you also acquire the timestamps simultaneously and store all the data with the timestamp so that will help you later to integrate your data with time, right? See, agriculture, there are many robots that you can invest in. Firstly, wheel robot, but wheel robot is not going to help you unless it is a multi-terrain vehicle kind of wheeled robot, like a Mars rover. If you remember, you must have seen those videos. You can make a wheeled robot like this, which can move in multi-terrain also. So those robots you can look for, not necessarily just the armed robot that you are going to study here. If you want to do something, you need to attach these arms on top of those mobile robots. The first thing that you should invest in is probably a wheeled robot, which is a multi-terrain kind of thing. Right? Articulated arm is more useful in agriculture. Okay, articulated arm, which can be mounted on wheel robot, and you see it has better reach and mobility. You see, it is very much redundant in nature. If it is 7-dog, it can go anywhere. It can pluck the fruits. If you just Google around, you will find out there are fruit plucking robots also which are there. So you will find these kind of robots are there already. Okay. So any specific query apart from industrial robots, I would prefer answering you specifically on the forum that you have. That is the Google group email ID that you were given. You can post it there. I'll definitely try to answer them. If you have 2 degrees of freedom legs, what will happen? Can you yaw? Can you yaw? Let's say you consider yourself. If you are a biped, you have 2 legs which cannot do this motion. What will happen? Right? So you can just go this without bending your ankle, right? You won't be able to take turn. Right. So that is the reason even quadruped robot, they are also stuck with that kind of architecture. So that is the reason it has 3 degrees of freedom. With just 2 degrees of freedom on each leg, it may not be able to turn, right? So that is the reason. Okay. And sometimes you can use drag-based technique to turn still, but keeping your leg straight and parallel, it cannot be done. So 2 degrees of freedom is required to make this motion, but the third motion, which is a spanning motion kind of thing or yawing kind of thing, so that is possible only with 3rd degree of freedom, which is there. So look carefully those videos which shows this. So what is that third degree which is helping it to do that? Right. So yes, this is a very good question. How you can decide upon kind of degrees of freedom of each leg of a multiped system like quadruped. Right. Okay, I assume if there is no other query from any other participant. If at all anyone else joins, I can answer them. Yes, this session is live. This was live for quite a long time, and yes, it is. It will remain here forever. So you can always come back to this live recorded session, which is there, going to remain on this YouTube channel. You can click on this and watch this video later as well. So don't worry, it will be there. So I would expect much better, much more participants next time. Thanks a lot for being with me. So I would end here. That's all. Thanks a lot. So be excited, be with the videos which are there that I am sharing time to time. Enjoy the course. Thanks a lot. See you. Bye-bye.